When excessive bleeding cannot be stopped, an injury can turn into a life-threatening emergency. When traditional methods such as applying pressure or using a tourniquet are no longer an option, say for the head or abdomen, a hemostatic agent must be applied.
Hemostasis can be achieved naturally in the body when platelets aggregate around and clot damaged blood vessels. To reinforce this clot, the soluble protein fibrinogen can be delivered from the liver to the wound. Then the enzyme thrombin catalyzes fibrinogen into the insoluble protein fibrin. Fibrin is then woven into a mesh over damaged cells to prevent further bleeding. To expedite this clotting process, excess amounts of fibrin and thrombin can be applied to seal the wound.
Current hemostatic agents that are being marketed utilize a variety of materials to promote blood clotting. The first are mucoadhesive agents that form a seal independent of the body's clotting process upon contact with blood. The second method is the use of factor concentrators that absorb water on the site and concentrate clotting factors on the wound. The final method is the use of procoagulants that accelerate the body's own coagulation process. The downside of these products is that they take too long to clot, they can't be applied in deep wounds, and they might leave residue within the body that is difficult or impossible to remove. Our environmentally sourced active ingredients, thrombin and fibrinogen, derived from salmon blood, simulate the body's own hemostatic mechanism.
There are several constraints that must be taken into consideration before designing a processing facility. These include physical location, product type, effectiveness and biocompatibility, legal and financial concerns, as well as sustainability. Our facility will be located in Punta Arenas, Chile, which is home to Cermaq, the world's third largest producer of salmon, which produces about 150,000 metric tons of salmon each year. Our facility will be in close proximity to the salmon processing plant to ensure expedient and low-cost delivery of our raw materials. In order to compete with current products in the market, our products should strive to have a shelf life of 5 to 6 years and be able to stop bleeding within 2 minutes of application. We must also adhere to local laws that govern energy use and proper waste disposal of hazardous biological and inorganic wastes. Goods transported from our facilities must also meet transportation standards set forth by local and international law.
In salmon, blood makes up about 3.5 to 4% of the fish's weight. It is only possible to collect up to 2% of that weight as blood using current technologies. Of the 2%, 78% of the contained plasma is recoverable, containing 1.47 milligrams per milliliter of prothrombin and 1.57 grams per liter of fibrinogen. Our process starts with the purchase of salmon blood waste from the salmon producers located in Punta Arenas, Chile. By purchasing from several suppliers, we ensure we will acquire the necessary raw material to meet our scheduled production rate of 44 kilograms per year of thrombin and 479 kilograms per year of fibrinogen. The salmon blood waste will be loaded into refrigerated trucks at the supplier's processing plant and shipped to our facility, where the waste will be processed into thrombin and fibrinogen to be used in our final product.
Before the raw salmon blood can be processed, it must first undergo a sedimentation tank. In this step, solids will be removed from the blood. This will decrease the fouling effect in our system and increase the overall longevity of our equipment. The blood can then be centrifuged to separate out the plasma, red blood cells, leukocytes, and platelets. The plasma, containing our desired product of prothrombin and fibrinogen, can then undergo a series of mixtures where they can be selectively precipitated. Prothrombin will undergo a reactor where it can be converted to thrombin, and fibrinogen will undergo an ultrafiltration shot to be purified. The two products will then be processed, dried, and then packaged to be delivered to our customers.
Our economic analysis focused primarily on the value of our two components, thrombin and fibrinogen. We estimated that our facility could process 1,100 tons of salmon blood per year. This would yield 650 tons of salmon plasma per year. Using data from Sigma outreach and low extraction rates, we estimated that we could produce approximately $180 million worth of fibrin and thrombin per year. This puts us well into our goal of a $20 million revenue per year.